All right, so what are the y coordinates for the solutions to this system of equations? So it gives us two that we're probably not used to. Now, we can, the easiest way, if I'm taking the test, I want to do this and get the answer right, I'm just going to graph them. I'm going to go to Desmos, plug them both in, boom, it'll show me where they cross. They're going to cross in two spots. But let's say we can't use Desmos because we want you to be able to use your head. Now, I will show you Desmos graph in a minute, but let's use our head and figure this out. Now, first thing, usually we have an equation where you have this x squared plus 6x plus 3y. We're not used to y. We could move the y over and then divide by 3 and simplify it. But here's what I'm going to notice. I'm just going to take, it doesn't really matter, but I'm just going to take this. Let's do this. Let's take this equation here. And we can get y by itself. We can get x by itself, right? We could do that. So let's go ahead and do that. Let's get, it's going to be easier. We're just going to put y by itself. So I'm going to get y by itself. So I'm going to move the x over. So I'll subtract x from both sides. So it goes over negative. Subtract 20. So it's going to go over negative also. So y is equal to the opposite of x minus 20. I'm now going to replace this y right here with that. So let's go ahead and do that. So I have x squared plus 6x plus 3 times the opposite of x minus 20 plus 6 equals 0, right? I'm going to distribute through. When I distribute through, I got, let's see, minus 3x plus 3 times negative 20 minus 60 plus 6 equals 0. So we end up with x squared plus 3x minus 54 equals 0. I can see, oh, a 9 times 6 gives me this 54, yet will give me the 3. So this is an x plus, and we'll do an x minus. So I need to gain more, so I'm going to put the 9 here, the 6 here. Positive 9 times negative 6 is 54. Negative 54, check. And 9 plus negative 6 gives me plus 3. So that's what it breaks down to. So in this case, x is negative 9, and x is negative is positive 6, right? So that's the values that would make this true. Negative 9 and positive 6. And we want to jump and grab the answer here. But wait, that's x's values, right? We want the who values, the y values. So I'm just going to simply come back to this rearranged equation I have right here, or even go in right here. So y is equal to the opposite of x, the opposite of negative 9, which is positive 9, take away 20. That gives me negative 11 for one of the y's. The other y, I need to plug in a 6. So the opposite of 6 minus 20, negative 26. So I'm looking for negative 11 and negative 26. That's the y values. These were the x values. That's how they tried to trick you. Let's go look at the Desmos graph. I graphed it. Now we notice it wants the y values. Right here is a point of intersection. The y value is negative 11, and the y value here is negative 26. And again, all I did right here, you can see I graphed the equations. That would be the easiest, fastest, most secure way of getting your answer, because you probably won't make a mistake. But this is the mathematical way we would do it by hand if we didn't have Desmos.